All right, so let's get started. So welcome to this webinar. Today we'll be introducing a new energy storage offering from OutBack Power. We're happy to introduce OutBack Power's new Pure Lead Carbon PLC, Pure Lead Carbon PLC batteries. My name is Gwendolyn Espy. I'm an applications engineer for OutBack Power and have been for about a year and a half now. So I'm happy to be doing this for you guys. In this webinar, we'll be talking about what is the EnergyCell PLC. We'll classify what applications best fits the PLC and some technical highlights such as specifications, programming, warranty, etc. This webinar is for installers or end users who are comfortable and experienced with lead acid battery technology and programming. Now, we won't be covering the basics of energy storage. We won't be covering general lead acid technology or other battery technologies. We'll just be talking about the EnergyCell 200 PLC specifically. So speaking of that, if you'd like to get an introduction to battery technology, there is a wonderful webinar posted on our OutBack Power YouTube channel, and it's called Storage for Renewable Energy Overview. So if you'd like some type of introduction to different battery technologies, that's a really good video to watch. All right, so we'll just get an hour. Everyone will be muted throughout the webinar. During the webinar, feel free to ask relevant questions through the questions or chat box. I don't know what it's called for you guys. And then we'll do a short Q&A at the end. All right, so let's get started. All right, so today we'll be going over the following topics. What is EnergyCell PLC? We'll do a technology overview. We'll talk about the product features and benefits. And next, we'll be talking about the EnergyCell PLC application. So the EnergyCell product lineup, and then also talking about the system edge packages with the PLC in them. And last but not least is more of the technical information. So this is more of the practical stuff. So specification, we'll go over some programming and settings, and then some warranty information, and then also an optics RE overview. Okay, so first is what is EnergyCell PLC? Okay, well, the PLC stands for Pure Lead Carbon. Pure lead is a high quality material. It increases the life and performance of the battery. You'll see that later that the PLC has a high cycle life at 50% depth of discharge. It has a greater temperature tolerance versus traditional VRLAs. We have a specification comparison chart later where you can see the differences between the PLC and our current offerings. And it has a shelf life of 24 months. The carbon additive, we call it the pure lead carbon, is on the negative electrode or the negative plate, which is pure lead. So this carbon additive reduces the rate of sulfation. Sulfation is when small sulfate crystals form on the negative plate, and it causes less negative active material to be available for use. So it reduces the capacity of the battery. And adding carbon slows that process down. Now, during normal use, these crystals form. They're usually not harmful. During charge, they're reabsorbed, but if they're left in a partial state of charge long enough, some of the crystals can attach to the negative plate permanently. So as a result, you have less capacity available. So with the carbon additive, like I said, that slows this process down. The battery the battery is ideal when there is a full refresh. This battery is ideal when a full refresh charge isn't possible immediately, or for what other people say partial state of charge operation, which is that PSOC, stands for partial state of charge. Okay, so here we have a comparison between a traditional valve regulated lead acid and a pure lead plus carbon battery. On the left, we have a traditional VRLA material cross section. You can see that the crystal distribution is uneven. It it can be easier for sulfate crystals to latch on and for corrosion to occur with this. With the pure lead plus carbon, the material is more even and smooth. This is the pure lead component, so this gives less opportunity for corrosion to occur. Also, with the pure lead carbon material, it enhances the operational temperature range, and we'll go into that later as well. So the carbon additive, it reduces hard sulfation, and it mainly improves performance such as capacity, cycle life, partial state of charge, high current, etc. And the pure lead reduces corrosion and results in longer life, longer shelf life, and higher temperature tolerance. So the PLC offers great features and benefits. So it has a great deep cycle life. I'll be repeating this over and over, 3,000 cycles at 50% depth of discharge. It has excellent partial state of charge cycle performance. The high quality material, so that's pure lead and carbon, ensures longer life and superior performance versus traditional lead acid batteries. It has excellent charging acceptance with high charging efficiency. So what that means is that you'll be able to charge these batteries faster than the average VRLA. And that's that carbon component. It also has extended float charging life due to float charging current. So the high power and energy density and a compact footprint. It has a wide operating temperature range. Long shelf life, so 2 years with low self-discharge rate, low maintenance and no watering maintenance. So it is industry-leading a lead acid warranty. So for the US and Canada, and I'll be repeating this a few times, a 6-year full replacement. For the EU and the UK, it's 5 years full replacement, and the rest of the world, it will be a 4-year full replacement. It has a proven history of safe and reliable performance with the lead acid technology. And the nice thing too is that these batteries are 96% recyclable. So that's something to think about. All right, so this is the evolution for the EnergyCell product line. So we're going to start out from the left and then go to the right. So in 2011, we introduced the EnergyCell RE. So this is a 200 amp hour battery and the first 12 volt front terminal VRLA deep cycle in renewable energy. This series uses pasted lead calcium tin plates, and it's designed for regular discharge charge cycles. So its intended use is for backup, off-grid, and renewable energy sites with OutBack inverters, charge controllers, and other devices that require the use of deep cycle batteries. In 2013, is the EnergyCell GH, which was introduced. So this was the first 12 volt front terminal VRLA pure lead used for grid tie emergency backup in renewable energy. So this series uses unique lead plate technology called thin plate pure lead, or TPPL, is intended to receive continuous float charging under normal conditions when utility power is present. So its intended use is with grid hybrid systems. So that's a GH. So this is particularly used for renewable and grid tie emergency backup applications with occasional interruptions, but the key is minimal cycling for this type of battery. So the pure lead plates are great for long float service life in these battery backup applications, and you'll see that also with the PLC. The EnergyCell NC, so that stands for nanocarbon. So in 2015, we introduced this battery, which was the first 12 volt front terminal to use the nanocarbon technology for a partial state of charge applications in renewable energy. So this series uses a proprietary negative plate formula to achieve greater cycle life. And it's designed to operate in a partial state of charge applications. So this is intended for energy arbitrage, self-consumption applications. In other words, for grid tie self-consumption. And now we have released the EnergyCell PLC, which is the first VRLA 12 volt front terminal battery to use pure lead carbon for increased cycle life and extended float life. So this series uses a hybrid combination of the pure lead plates and the carbon additive on the negative active material designed for cycling and partial state of charge application. So this is the evolution of the 12-volt EnergyCell product line. Okay, so now we're going to talk about the EnergyCell product lineup. So we'll go over what applications the EnergyCell 200 PLC can perform in and our system edge offerings with these batteries. All right, so here is a product lineup with the appropriate applications for each battery. This now includes the EnergyCell PLC. So PLC can be used for off-grid applications. So you can see that here. So it has excellent deep cycle capability. Next, it can also be used for grid tie self-consumption. That's in this area here. And this is due to its excellent partial state of charge operation from the carbon additive. And that's why you see the nanocarbon also in this category. And then last is the grid tie backup. So extended float life due to the pure lead plates. The pure lead plates are great for long float service life in these battery backup applications. Remember that the GH batteries are made of, which is also here, they're made of thin plate pure lead. So that's why you also see that in this category. So the nice thing about this is that the PLC batteries, they're really great for all of these applications, which is really nice that you don't have to think about that. So here's a different way to see the product lineup as well. So this is the product lineup in reference to the effective capacity needed for the application. The Energy PLC is excellent for applications where the energy capacity available to loads needs to be between 1 to 20 kilowatt hours. So you can see here, it's in the 1 to 10 effective kilowatt hours to the 11 to 20. So between the type of use profile, and by that I mean here, right? Whether it's the an off-grid battery backup or grid tie self-consumption, and the effective energy needed, meaning between 1 to 20 kilowatt hours effective, the EnergyCell can be a one-stop shop, which is really nice. So like I mentioned before, the PLC can be used for many applications. So the PLC it's excellent for off-grid applications as it has excellent deep cycle capabilities and excellent cycle life. At 50% depth of discharge, it can perform 3,000 cycles. It's also really good for grid tie self-consumption. It has excellent partial state of charge operation. And with this type of application, the battery can get greater than 3,000 cycles. And that's because some cycles in this type of application, some cycles will be 10% depth of discharge, some cycles will be 20, and that will get you better cycle life. And we'll talk more about that later. Lastly is the grid tie backup application. So that's one where the PLC also does well as it has extended float life due to the low float charging current. So we also offer these batteries in our system edge packages which are designed for convenience, value, and flexibility. OutBack Power System Edge pre-bundled packages take the guesswork out of selecting the right combination of energy storage and power electronics. And we'll talk about some of these packages in the next slide. So first we have our cabin series. So these systems are for off-grid applications. This specifically is the System Edge 320 PLC. It has 3.6 kilowatts of power available and 9.6 kilowatt hours of effective energy available with 2 strings of the PLC batteries. So this is perfect for off-grid weekend cabins or modest load permanent residences. The System Edge Cabin Series delivers enough power and storage to support a typical load profile made up of, for example, a continuously running refrigerator, maybe 10 lights, a ceiling fan, a computer, and a well pump, something like that. So here is what the cabin series 320 PLC is composed of. So we have a Flex Power 1, specifically with the VFXR 3648A, which utilizes a 48-volt battery pack. So its AC input and output is 120 volts AC and 60 hertz. The EnergyCell 200 PLC is included along with the integrated battery rack. We often call it the IBR for short, and that's this guy right here where these batteries are in. So that's the integrated battery rack. It also includes rapid shutdown solution and optics. So like I said, this is really good for a light amount of daily loads, like the ones you would see in a cabin. It's important, however, to know how much energy you need for your system. In short, these packages doesn't replace load calculations and system sizing. It just simplifies purchasing for a one-stop shop. So you really do need to understand your loads, essentially, to make sure that this is the right package for you. So next is also part of our cabin series, which is for off-grid applications. This is now the 420 PLC. So this has now 4 kilowatts of power and has 9.6 kilowatt hours of effective energy available with 2 strings of these batteries. The effective energy available is the same as the 320. So this series can deliver the same energy to the same type of load profile as the 320. It just has a little bit more power when it comes to the inverter. So you have more surge loads or peak loads. Maybe that's why you would choose this package over the other one. So here is what the cabin series 420 PLC is composed of. So we have the Flex Power Radian 4048A, and this can output 4.0 kilowatts continuously and also utilizes a 48-volt system. Its AC input output is 120 volts to 40 and has a frequency of 60 hertz. The EnergyCell 200 PLC is included along with the integrated battery rack, just like the 320 PLC. It comes with rapid shutdown and then optics RE as well. So this one is good for a light amount of daily loads, just like the 320 PLC. But like I mentioned earlier, I want to emphasize this, is that you still need to understand how much energy your system needs. This does not replace load calculations and system sizing, right? It just simplifies purchasing. Okay. Lastly, we have our Villa series, which is also an off-grid package. So this one has 8 kilowatts of power available and has 4.4 kilowatt hours of effective energy. So this has 3 strings of the EnergyCell PLC batteries. The Villa series package can provide power and storage to support loads consistent with a modern residence. So light loads such as multiple refrigerators, TVs, computers, lighting, air conditioning, those are just examples. Like I said, you need to do your system sizing calculations to make sure that this is enough energy for the application. All right, so here is what the Villa series is composed of. So we have our Flex Power Radian 8048A, which can output up to 8 kilowatts continuously. It utilizes a 48-volt battery system. Its AC input and output is just like the 4048, so it's 120 to 40 and 60 hertz. The EnergyCell 200 PLC is also included, so we have, instead of 2 strings, we have 3 strings here. It also comes with the rapid shutdown and then optics RE. So here's a closer look to the PLC label artwork. It includes some specifications, warnings, and other information on the label artwork. So this is what you would expect to see on our PLC battery. So here we have our 20-hour rate, 100-hour weight, torque, etc. It just has some information. All right. So now we're going to go over some more technical and practical features on the PLC. So here is the specification for the PLC. This is available on our website at outbackpower.com. So if you'd like to study this longer, feel free to go to outbackpower.com. You can find it, it should be under our products. You should find EnergyCell PLC, and the data sheet should be there. So we're just going to go over some of these specs in the next slides. First, you might wonder, okay, what's the difference between the PLC batteries with your other batteries, right? So I made this, we made this table that kind of made the comparison. So it'd be a little bit easier to see the differences. So then maybe you could choose which battery might be best for your application. So I've highlighted in green the best specification when comparing the OutBack batteries with each other. So let's start from the top, and then we're going to work our way down, okay? So first is, okay, we have our OutBack product family. We have the RE on the left, the GH, the NC, and then the PLC. They're all 12-volt nominal, that's their nominal battery voltage is 12 volts. The 10-hour capacity in amp hours was only available for the 200 PLC, so we're just going to skip over that. Next is the 24-hour capacity. So here we have the GH. So the EnergyCell GH battery has a better 24-hour capacity overall, but if you look at the 200 NC and the 200 PLC, they aren't too far behind. So the GH is at 189, the NC is at 181.4, and the PLC is 182. So there's just about a 7 to 8 amp hour difference there. Next, the 100-hour capacity, they're all 200 at the 100-hour capacity. So they're all tied there. Cycle life at 50% depth of discharge. The PLC battery conquers with an impressive 3,000 cycles, which is 400 more than the NC. It is 2,350 more than the GH and 1,200 more than the RE. So quite a lot, quite a huge difference there. Dimension-wise, there was some variety. So here's like 22.1 versus 22.01 versus 22.1. They're pretty much the same. So I didn't want to kind of pick at them. So they're essentially the same footprint. So not a huge difference. They're all going to fit into the same, into an IBR, the integrated battery rack. So yeah, not much of a difference there. The weight, now when it comes to weight, the PLC is similar to the RE and the NC. So here we have, they're all about, 130 pounds, 131 pounds. The GH is still the lightest battery between the series at 116 pounds. So if that's important, there you go. Okay, so the shelf life. So the PLC has a total shelf life of 18 months at 25 degrees Celsius, which exceeds the RE and the NC and is equal to the GH. So, and then for the float life, the GH is the best for a backup application as it has the best float life of 15 years. Now the warranty, let's see. So the chemistries they're all different. So there's not really anything to compare. So we're just going to go to the warranty. The RE has a 1-year warranty, the GH a 4-year warranty, NC 2 years, and then the PLC has a 6-year warranty. So, so that's for the USA and Canada, 5-year full replacement for the EU and the UK, and then for the rest of the world, it's 4 years. So here we're representing the USA and Canada. The maximum operating temperature, so the RE has a wider range here. So we have -40 to 71. Compared to I guess they all have -40, so we want to look at the high end. So 71 degrees Celsius versus 50 versus 60 versus 65. So with the temperature, the RE has a wider range by 6 degrees Celsius or 11 degrees Fahrenheit on the high end. For the application where high temperature might be 149 degrees Fahrenheit, either the RE, so if we had an application where we knew the temperature would be 149 or 148, either the RE or the PLC could work. So it just depends on your application, what might be the best selection for you. All right, so the effective storage. So they're all pretty much the same. So we use the 100-hour capacity for that. So they're about the same. So the assumption is for that is that it's 100-hour capacity, 48 volts, and we're also assuming 50% depth of discharge to get that number. Now, for the total kilowatt hours delivered over the life of the batteries, now that's a different story. So in the combination with all of the number of cycles and the effective storage per 48 volt string, and we're also assuming a 50% depth of discharge for each cycle, the total kilowatt hours delivered exceeds all the batteries at 14,400 kilowatt hours throughout the life of the batteries. So yeah, so that's something to consider as well. So we already went over the variety of the applications that PLC can be used. So let's take a look on how that compares with the other batteries. So the RE on the far left is best for off-grid applications. The GH is best for grid-tie battery backup. And you can certainly see that with the float life category, right? The NC best application is for self-consumption. But finally, the PLC can be used for any of these applications. It's good for off-grid, it's good for grid-tie self-consumption, it's good for grid-tie battery backup. When it comes to the variety of applications, the PLC batteries are the most flexible. All right, so now we're going to go into some details on the specifications. Now, we won't go over each specification, but I try to pick the most practical ones to go over. So the first one is the dimensions of these batteries. So they're about the same. I already talked about this, but they're about the same as the other 12-volt front terminal batteries. And what this means is that this can fit into an IBR, or integrated battery rack. IBRs, they can hold either 2 strings or 3 strings of batteries. They're different SKUs, so you'd have to decide up front which one you want. So if you're used to the footprint of our other 12-volt front terminal batteries, the PLCs will be about the same. There's not much different here. So these batteries are very similar footprint, and overall the size of our front terminal 12-volt battery. So you would wire these batteries together with a bus bar for simplicity. So when it comes to strings, 1 string is the best. We generally don't recommend more than 3 strings. And the reason for this is the possible issue of when current gets delivered to the batteries. It doesn't quite split evenly between the parallel strings, so it's never exactly equal. A slightly weak cell or even maybe terminal corrosion can cause a battery string to receive less current. And over time, the string will fail and degrade earlier compared to the other strings in parallel with it. So a way to reduce this is to reduce the number of strings. So like I mentioned, 1 string is best, and then we just recommend no more than 3 strings. I know sometimes you need more capacity, so you have to have more strings, but no more than 3 strings is recommended. And here we just have some specs laid out. So we talked about weight, dimensions, and this is just how to wire it. So some of the torque recommendations or yeah. So in the past, so we're going to talk about capacity. In the past, I've gotten questions on energy density. So I just re-provided that information here. So we have the weight and the volume here for those who may want to calculate what their appropriate with their appropriate hour capacity for your application. So you could decide, if you're discharging your batteries over 100 hours, and you can use these numbers to figure out what your energy density would be. So I just provided that for you guys. Here we have the hour capacity for the PLC batteries. So most of you probably know this, but I'll say it. So as the rate of discharge increases, the battery's available capacity decreases. The faster you discharge the batteries, the less capacity you have available. So we're working with time, we're working with current, and we're working with available energy. They're all related. So here we have our discharge, so this discharge in hours. So this is assuming 100% discharge. Okay, so if you were to discharge the batteries 100% in 1 hour, for example, right, you would have 104 amp hours of energy available if you were to discharge 100%. So this would mean you would be discharging your batteries at 104 amps. Now, if you were to discharge your batteries in 100 hours, so we're just going to go all the way to the end here, you would have 200 amp hours available. That's energy available. That's assuming 100%, which you shouldn't do, but this is just simplifying. Then at that point, you'd be discharging at about 2 amps. So the faster you discharge your batteries, the less capacity you have available. So generally, batteries should only be discharged to 50% depth of discharge maximum. Although this is really up to the installer, designer, and programmer. They really have the control on how far or how deep you discharge those batteries. We have other videos that go over how to use this information for your design, so I won't go much more into this. Just looking at this chart here, so we have an 8-hour capacity of 160 amp hours per battery or string, and then we have a 24-hour capacity of 182 amp hours per battery or string, and then finally 100-hour capacity of 200 amp hours. So to increase amp hour capacity, besides maybe drawing lower current, you just need to add more strings in parallel. But remember, we generally don't recommend more than 3. Below this amp hour, so these are all in amp hours here. That's the units. The second row is the kilowatt hour capacity. So this is assuming at your nominal 48 volts. So this just gives you the general idea in case that's the units that you're used to. Top row, amp hours, bottom row, kilowatt hours at your 48 volt nominal. All right, so we're going to talk about performance. So the round trip efficiency of your batteries is 95%. The cycle life is presented on the graph to the right. This cycle life, so if we look here, the 50% depth of discharge, we have about 3,000 cycle life. Now, in a grid tie self-consumption application, you typically have, so here I have that here, you typically have cycles that range between, 5%, I just chose 5%, 5% to 50% depth of discharge. It really can be anywhere between 0 to 50. So you might fully charge and discharge, let's just call this 20%, fully charge, discharge 50%, fully charge 20, fully charge 30 or 40%. So so when you consider that type of application, so let's look over to the right. So at 10% depth of discharge, you have about 8,000 cycles. Looks like a little bit less. 20%, 7,000, about 7,000 cycles. 30%, about a little bit over 5,000 cycles. So now these applications or this chart assumes 100% or 10% depth of discharge 100% of the time. So if you were to have a few cycles that were 10% and some that were 20% and some that were 30% and maybe half that were 50% depth of discharge, then you would average out to more than 3,000 cycles. So in other words, grid tie self-consumption, this type of application, or any application where you might have light depth of discharge, some cycles that might have light depth of discharge, you could expect to see more than 3,000 cycles. However, don't forget that the cycle life can be affected by temperature. Now, in our PLC manual, which is available on our website at outbackpower.com, it shows the effect of ambient temperature on a typical battery life. So if you want to read up on that, all of our PLC documentation literature is on the website. So programming is the #1 question that we get from most customers, even for batteries that we don't make. However, the voltage and time targets should always be provided by the manufacturer. So here are the voltage and time targets that should be programmed for the PLC batteries. So these batteries should not be equalized, as most AGMs should not. So here we have the equalized voltage and the absorbed voltage to be the same. And then we just set the timer for the equalized voltage to 0 just to be safe. All right, so the absorbed voltage should be set to 14.1 volts for a nominal 12-volt system. And then you just multiply that by 4 and you get 56.4 for your 48-volt system. Float voltage, 13.5 for a nominal 12-volt system and 54 volts for a 48-volt system. Refloat will be 13.2 and then 52.8 respectively. And then lastly, we have our rebulk at 12.9 and then 51.6. The maximum charge current per battery is 50 amps. So what this means is that the maximum current going through any one battery should be 50 amps maximum. So this essentially equates to a 50 amp maximum per string. Because you have 4 batteries in one string, that does not mean you can take 50 amps, multiply it by 4 batteries, and then have 200 amps going through that one string. And we're just going to take a little bit of a deeper dive into here about that. So I have these lovely diagrams with our PLC batteries. So like I said, the maximum charging current, the spec says, is 50 amps per battery, right? So this means that the maximum current going through any one battery should be 50 amps maximum. So on the left, we have 4 batteries in series, or you could call it one string, 4 batteries. So if you were to have 50 amps flowing into the batteries, that 50 amps will go through all of those batteries. That's a 1-lane road, and that 50 amps only has one route it can take, and that's to go through each of these batteries. So if you had one string of batteries, your maximum charging would be 50 amps here. However, on the right-hand side, we have 3 batteries in parallel, or 3 strings, right? So this wiring has a fork in the road, right? It has 3 forks because we have 3 strings. So we have 150 amps coming in, all right? We're talking about an ideal situation. This is not real life, but ideally, right, the current would split evenly between the 3 strings. Like I said, we know that this isn't real life. That's not really what would happen. They'd be slightly different, but for this example, we're just going to assume that it splits evenly between the 3. All right, so that means that 50 amps will be going through each of these batteries, right? So, and then once they go through the batteries, they recombine, and then the exit is 150 amps. So in this case, the maximum current going through any one battery will be 50 amps maximum on the far right-hand side. Ideally, this is the ideal lab situation. So this wording essentially will equate to 50 amps maximum per string. Okay, so hopefully that was clear. Okay, so now we're going to talk about warranty information. This is disclaimer, the slide does not cover the complete warranty document. It is just highlighting some topics included in the warranty. The full warranty document is available at outbackpower.com and should be fully read and understood. Me spitting out the whole warranty document, it doesn't make sense to do that here. So I just figured I know it's important for you guys. I just wanted to talk about it, at least highlight some of the things, and then hopefully you guys can find the time to read through it. All right, so defects in material and workmanship is covered. So a battery is considered defective if it fails to deliver 70% or less of its rated capacity during the claimed warranty period after fully charging. So this would be your warranty claim period would be 6 years for the US, Canada, 5 years for the EU or United Kingdom, and then 4 years for the rest of the world. So I listed some of the requirements. They're not limited to, I just kind of wanted to touch base on some of the warranty information. So you have to keep the batteries above 2.05 volts per cell. You do have to, any routine or daily discharge of more than 50% capacity. So if you do design this to be, 80% depth of discharge, that's what the design is for, then that's not covered. So you have to have you have to make sure that the maximum designed or routine daily is 50% at its maximum. There are temperature limits that you have to be aware of. So there's an average temperature limit, a high temperature limit for more than 30 days, and then beyond the operating temperature limit. So these details are described in the warranty statement. And then there's also time between recharge. So failure to charge within 48 hours of a discharge. So you have to make sure that you do charge these batteries back up within a 48-hour period. So they shouldn't be left discharged for more than 48 hours. Like I said, there are more details in the warranty statement. It's a document. I just wanted to highlight some of the factors since I know it's important to you guys when considering a battery. So yeah, if you want to read up on it, the full warranty statement is on our website. Okay, so we're almost done. Anyway, so we also offer Optics RE with our OutBack power systems that have M83 or M83S. What's great is that this allows you to monitor the battery performance and make adjustments remotely. So I actually want to take a look and kind of show you guys what this looks like. So we are going to explore that. How do I stop this? Okay. All right, so this is a system that we have in Germany, actually. So we're taking a look. So it's about almost 8 o'clock in Germany, 8 p.m. So this is the dashboard. So this is kind of, actually, let me show. Yeah, this one's more interesting. Okay. So this one is one that's in Seattle. So this is actually one of our coworkers. This is his system. So this is Optics RE. So you can monitor remotely your system. You can actually make adjustments. You can see how your battery is performing, see how your system is performing. It's really great. So here is the dashboard. You can see your information. So you have your solar, you have your batteries. We can include the inverter data. What is the inverter doing? How much power are you buying? It looks like right now he is having it's about 10, almost 11. So he has about 540 watts. He is selling back to, let's see, get out of here. So he is charging his batteries and he's selling 200 watts back to the grid. It must not be very sunny right now. So this is just a great way to check it out. And then you can click down here and see what your batteries are doing. On the far left, you can change between amp hours or kilowatt hours. So this is energy. On the far right, you have your state of charge, which you can change this axis to be voltage. And you can monitor your battery voltage, what was the high and low for that hour. If it gets super low, then you can see what's going on, maybe change your settings. You can check temperature in Celsius and Fahrenheit as well. So, and then if you hover over the battery, you can see what the state of charge is. If you have a, you can see what the state of charge is. You can see, it looks like he has a battery monitoring system. So he can see how much current is going in and out of his shunts that he's monitoring. So yeah, so this is a really great way to see how well your battery or how well your system is performing. And the nice thing is you can make adjustments remotely. I don't have access to anybody's system except for 2 systems that are OutBack powers And but we can still check out what he has here. So here he has his battery monitoring system, his charge controller, his inverter, and his Mate 3S. So we are going to go into his inverter and then see what his settings are. So for some reason there was an issue with, let's say that the end user was messing around and changed some settings on accident. You can easily come here and then change the settings as well. So you can change it back to what they need to be, or if you need to make a slight adjustment, you can do that remotely. Let's see, and then so the battery charging, this has all of the kind of battery related settings. You also have auxiliary control, so you can't select these, but you can change like auxiliary controls based on your battery voltage. So your batteries are low, you can disconnect maybe some loads so that you can really protect your batteries. The next nice thing is the event history. So if for some reason you do know that something in your system went wrong, maybe your settings got messed up, you can actually see what changes were made. So here, for example, we can see on site somebody had changed the absorbed voltage from 54.6 to 58.8. So if you didn't do that, if you're the installer or designer, it's like, hey, that's not how it should be. You can change that remotely, which is really cool. So you can see who made the change. So if it was via optics, it would say whoever the user is, and if it was done manually on site, it will say on site. So this is really good for troubleshooting too. So let's try. Let me see if I can. What's really cool is I have access to everybody's, but I can't make any setting changes. I can just see them. It's really nice for troubleshooting. So all right. So I can go, looks like this device is also selling. I think I have access to this one, so I'm going to click on it. Yeah, so I can actually change these settings. So if I needed to change this to 59.2, I can do that. I'm not going to, but I could make these changes and then press apply. But I'm not going to do that. So auxiliary control, you could do a DC divert. So all of these kind of look at or load shed. It looks at the battery voltage, and you can shed some loads if your battery is being compromised. So yeah, that's a little bit about optics. I didn't want to go too deep into it, but I just thought it's a cool feature since we're talking about batteries. Okay, cool. So it is, what time is it? All right, so we have about 10 minutes left. So I'm going to go ahead and look at some questions that we might have and see what we can do. So if you have any questions, oh, looks like we have a ton of questions. So if you have any questions, feel free to ask them now. And if I don't get to everyone's, I will try to answer them personally later. All right. We have a lot of questions. Okay. So maximum charge rate, that is your 50 amps. So I think I answered that. I think that might have been asked early on in the presentation. All right, so we have some questions about, it looks like some questions about energy density. So I think I provided that information. So in case you needed to look at that. So So it was watt hours per kilogram, watt hours per liter, etc. So if you want to, let's see if there's, I don't know if we have that in kilograms. Oh yeah, we do. So here, so on the spec sheet, you have your 59, so it's 59 kilograms. You can easily just look at whatever your, you have your amp hours. So to get watt hours, you just multiply by your voltage. So you can get that. And yeah, and then you can just use your, use those units to get those densities. See, I knew that was a popular question. Okay, what is the price or cost? So, we sell these through our distributor. So if you want price or cost, you have to ask your local distributor for that information. So there's a question here, but I'm not sure what the question was. So I'm just going to say it. Maybe there can be some clarification down the road. Okay, so it was FM 100 or FM 80. So I'm thinking they're asking if these batteries work with that. So the FM 100 and FM 80 work with lead acid batteries. Yeah, that should be fine. So they work fine with these ones. What? Hold on, let me look. Okay, so I think I answered this question. The spec sheet says max charge rate of 40 amps. If you put two in series, does that mean increase to 80 amps? No. It's still 40 amps per battery. So if you have another one parallel, then you could increase it to 80 amps because then it would split between the two. So first of all, it's 50 amps per battery. So 50 amps maximum for any particular battery. Oh. Okay. Does the 6-year warranty apply to all markets, including international? I think I answered that already. So 6 years for Canada, USA, 5 for EU, UK, and then 4 years for the rest of the world. Okay, so it says PLCs still limited to 3 or fewer strings. How would they do in 4 strings if additional capacity is needed? So the 3 or fewer strings, that's not limited to the PLCs. These are just generally lead acid batteries. This is just a general recommendation. So this applies to all of our batteries. So with any lead acid batteries, there's a possibility to that one string might have a bad cell or one string might have a bad battery, causing that whole string to get less charge. So that's not applicable to only the PLCs. So there's a question, no plans to release, what time is it? Okay. No plans to release the PLC in 2-volt individual large cells. Not that I'm aware of, but I'll write that down. Yeah, not that I'm aware of. So I think the answer is no. Somebody said I sounded like I was underwater, so I think I fixed that. Unfortunately, I just saw that right now. Let's see, where can we find out about pricing? So like I said, contact your local distributor. They're available today. So whoever you would normally buy from. Let's see. What has been the top selling feature have you noticed for the PLC versus other brands? I saw a chart, but I'm kind of basing this off my memory, so don't hold me to this, but I believe it's the total kilowatt hour delivered. So that is huge. And I think once you do get, a price from your local distributor, do the math, find out what the total kilowatt hours delivered per price would be. And I think you might find that to be pretty good compared to other, other brands and other technologies. Can the flex power dual inverter be used for this battery? I think you're talking about, let's see. I believe you're talking maybe about the FXR, the Flex Power 2. Yes, yeah, it can be used for this battery. I'm not sure if we offer this like pre-packaged, pre-bundled package with the PLCs with the Flex Power 2. So I think that's why we didn't mention it. Right now it's just with these packages that I mentioned. But yeah, these are lead acid batteries. You can use them as if they're any other lead acid battery. Okay, so a question is, what does VRLA stand for? So we have, VRLA is vent regulated lead acid. So that's AGMs and gel batteries. All right, we have 2 more minutes. Okay, hold on. Okay, so we have a question. I think I now understand the packages. Okay, so what are in the packages? So this was that earlier question, FM 100 or FM 80s. That's a great question. I know we're releasing these flex power packages with FM 100s. Let's see if I can find, I think I have the, yeah, I'll have to look back at that. I know we are releasing our things with FM 100s. I'm not sure what that transition looks like, but I'll write that down. Okay. All right, I'm probably going to take a couple more questions. We have a lot of questions. Okay, so this is a little bit off topic, but I'll just mention it. So someone was asking about lithium ion batteries and the availability of lithium ion. So we have partnered up with we have a relationship with Simplify, and that's a lithium ion battery. This battery pack is a drop-in for lead acid batteries, which is really nice. So if you are thinking about doing lithium ion for whatever your application is, that might be an option for you. But that's as far as I'm probably going to talk about lithium ion, because we're talking about the PLCs. Well, I think it's 7, or I think it's time. So if you have any more questions, I have access to all these questions. So if I wasn't able to answer your question, I have your email and I can reach out to you and get you some answers. So also, there's some people asking for some slides. We'll make sure to get PDFs to you guys afterwards. In the future, I'll try to get these available on there's a handout section, so I'll try to get those in there beforehand. I apologize for that. yeah, so I hope you guys found this really helpful. I try to make it practical, what you guys might be interested in. So, and these questions are excellent because in the future we take a look at these questions to make sure, hey, next time what can we include? What more details can we include? So, for example, warranty came up a lot when we've done battery presentations before. So that's why I made sure to mention it. So thank you guys so much. My name is Gwendolyn Espy, and yeah, I hope you found this valuable. All right, take care. So someone asked, are these slides available? We're gonna send them to you. We'll send you a PDF to your email. All right.